A radical new cancer treatment inspired by patients who seem to shrug off the disease could be tested next year. The technique uses potent cancer-killing cells from people with the strongest immune systems. These neutrophil cells, which form part of the body's first line of defense, are then multiplied millions of times and injected into cancer patients. They are believed to be a key reason why rare individuals spontaneously reject lethal cancers and seem to have miracle recoveries. The radical new cancer treatment uses potent cancer-killing cells from people with the strongest immune systems. Following experiments with mice, a British company is now preparing for early trials of the neutrophil treatment on a small number of patients. Alex Blythe, chief executive of Lift Biosciences, said, "We're not talking about simply managing cancer. We're looking at a curative therapy that you would receive once a week over the course of 5 to 6 weeks. Related articles previous. 1 next. No ifs, no buts, poll reveals huge support for push 2. Heartwarming moment stage 4 breast cancer sufferer. Share this article. Share script dm.later, bundle, function, if, dm.rotator, new dm.rotator, p18, page size, 1, page count, 1.0, active class, active, rotate, false, $, number p18.share, .on, click, function, dms.facebook.post related. Based on our laboratory and mouse model experiments, we would hope to see patients experiencing complete remission. Our ultimate aim is to create the world's first cell bank of powerful cancer-killing neutrophils. The team, along with researchers from King's College London, is initially focusing on pancreatic cancer, which is among the most lethal forms. Neutrophil cells form part of the body's first line of defense and are believed to be a key reason why rare individuals spontaneously reject lethal cancers. Each year around 9,618 people in the UK are diagnosed with pancreatic cancer and 8,817 die from the disease, which has a 5-year survival rate of less than 3%. Early laboratory tests have also shown that neutrophils can kill cervical cancer cells. Mr. Blythe said key advantage of neutrophils is that a donor's cells can be given to anyone without fear of serious rejection. They live in the body for only 5 days and disappear before the recipient's immune system has a chance to respond. Neutrophils kill cancer cells either directly, by destroying them with chemicals and antibodies, or indirectly by recruiting other immune cells. There is evidence that neutrophils may sometimes not recognize cancer as foreign and can even shield tumors from other immune responses. But when they do target cancer, they are highly efficient, wiping out 95% of test cancer cells in 24 hours. It is neutrophils with this ability that form the basis of the new therapy. The Lift team has collected thousands of the cells discarded as a waste product by blood banks, and is mass screening them for their cancer-killing potential in a laboratory. Those that pass the test are cultured and multiplied many times over using a secret process. The researchers are also working on a way of altering them to become even more potent. Professor Farseen Farzana, who is leading the research at King's College, said, "I was initially skeptical when Lift Biosciences approached us. It is something I don't believe has been done before, and producing these specific cells with cancer-killing ability is a notion we had not thought of. We are excited by the early results." The pilot trials, potentially starting in a year's time, would involve a small group of 20 to 40 patients with pancreatic cancer, or possibly a rare form of soft tissue cancer. Each participant would receive weekly infusions of potent neutrophils. One patient's treatment would require around 2.5 billion of the cells. So far, Lift Biosciences has received no government money and raised around £250,000 for early research from drug giants Merck, MedCity, which provides support for life sciences, and crowdfunding. Diana Jupp, chief executive of Pancreatic Cancer UK, said, "There are very few treatment options for pancreatic cancer, a disease which 93% of patients do not survive for 5 years. Immunotherapy is a very promising area for pancreatic cancer research, and one that we are funding as a charity. We know that pancreatic cancer puts up a barrier against immunotherapies, which makes it very difficult for them to reach pancreatic cancer cells and work as an effective treatment. It will be very interesting to see the results of this trial, and understand more about how well the treatment breaks down this barrier and how effectively this could work as a treatment for pancreatic cancer in the future.